Imagine that humans were able to create a spaceship that could travel at the speed of light. The spaceship has one mission: to circle around astronomical objects. Staying close to home, the ship first circles the Earth. The orbit is completed in 130 milliseconds, 7.5 trips around the planet in just 1 second. In its search for a more challenging lap, it then turns to the Sun, only to find out it can circle the Sun in a mere 14.5 seconds. It turns itself towards the center of our Milky Way galaxy, towards one of the largest stars ever discovered, Scuti. After traveling for nearly 9,500 years, the spaceship finally reaches the massive red hypergiant located in the northeast of the Eagle Nebula. Astounded by the red star large enough to fit 5 billion of our suns inside while shining 340,000 times as bright, our hypothetical spaceship begins its journey around its massive circumference. After a grueling 7 hours, it finally completes its orbit. If we replace our dear Sun with a Scuti, the red hypergiant would engulf everything as far as Jupiter. This video will explore the enormity of the stars that exist within the known universe. Is Scuti the biggest known star in the universe? Are there even bigger stars out there? What would happen if a star of this size were to explode? Stay till the end of the video to find out how astronomers were massively wrong about the size of the Scuti, and how the discovery of the Stephenson 2-18 challenged the very theoretical framework we use to understand the universe. So, what exactly does it mean to be the biggest star in the known universe? To explain that, we first need to understand how the Scuti was discovered, and what would happen, say, if it were to explode. The Scuti was first discovered in 1860 by the Bonn Observatory. That's no surprise though. Given its massive size and luminescence, it can even be observed in the night sky using just a pair of binoculars. However, the star's true size was not discovered until 2012, when astronomers observed it at the Very Large Telescope in Chile's Atacama Desert. The red hypergiant was thought to be the largest to ever be observed after this observation. Let's have a quick rundown before you get confused about what red hypergiants are. Stars have an aging process, much like all living things in the universe. They go through different stages that morph everything about the star, from their mass to appearance. The aging process of a star can be so intense that it is sometimes difficult to believe that they are all the same star. Only very large stars with a minimum mass of about 10 solar units will become a red hypergiant. Red hypergiants are stars aged enough to consume all of their core's hydrogen fuel supply. Hydrogen undergoes the process of nuclear fusion in the star's outer shell while helium accumulates in the core of the star. This helium begins to turn into carbon, and when the external and internal pressure gets high enough, this carbon will fuse into oxygen. This process continues to make the star heavier and heavier. Red hypergiants are the heaviest known stars in the universe. They take on a red color due to this nuclear fusion process, hence the name red hypergiant. These hypergiants have higher luminosity than other stars, and extensive research has shown them to lose mass rapidly. This mass loss is another defining characteristic of a red hypergiant. Due to their ability to rapidly lose mass, they have a relatively short lifespan of only about a few million years. That's a pretty short lifespan for a star bigger than multiple suns combined. After all these impressive numbers and comparisons, you must be thinking, what would happen if a celestial body as large as Scuti were to explode? Star explosions are not uncommon phenomena. They happen quite often, and they are known as supernovae. However, what causes a star to go supernova is losing physical mass, and Scuti does not have a lot of it left. Scuti is being eroded by powerful stellar winds as we speak. There is a strong possibility that the Scuti will lose enough mass to morph into a white dwarf one day. A white dwarf is a core remnant of a star, and it mostly consists of electrodegenerate matter. However, the Scuti still might explode, but this explosion won't be any different than a usual supernova. An ordinary supernova is a burst of light and energy emerging when a star reaches the end of its life. The interesting thing about supernovae is that they can outshine entire galaxies. They can radiate more energy than even the largest of stars combined. Now that's an explosion. If the Scuti were to explode, which can potentially happen in several million years, we will be able to see the magnificent explosion from Earth. However, given the massive distance between the star and Earth, we'll only get to see it several thousand years after the actual explosion. Due to this distance, the explosion won't impact the Earth. Talk about a glass half full. However, there has been controversy regarding the actual size of the Scuti. According to Sussex University astronomer Gillian Scudder, stars usually do not have defined edges. They have what is called diffuse edges, which means that there is no fixed line that demarcates where a star ends and space begins. On top of that, UY Scuti regularly varies in size, varying up to a margin of 192 times the radius of our Sun, meaning that the size of this massive red giant can be vastly different depending on the time of the observation. There is a chance that astronomers were wrong about the size of UY Scuti from the start. New measurements from the ESA's Gaia telescope indicates that we overestimated how far UY Scuti was from Earth. The updated numbers say the star is 5,000 light-years away from Earth. What this implies is that UY Scuti is much less bright and smaller than previously thought. So that brings us our question: is UY Scuti still the largest known star? The new data has concluded that our previous measurements for the size of UY Scuti were highly inflated. As it turns out, the star's diameter is actually only 755 times that of our Sun, nearly 1,000 times smaller than the previous estimate of 1,708. That's still astoundingly large, but it no longer places it as being the largest known star. In fact, there are at least 85 stars believed to be bigger than UY Scuti. The saying, "there's always a bigger fish," can't be any truer when it comes to stars in space. Given the vastness of space, there are always new stars being discovered, each pushing the theoretical limit of how large a star can be. Which begs the question, as of 2022, what is the largest observed star? The throne once thought to belong to UY Scuti is now taken by the ginormous Stephenson 2-18. Located in the Scutum Centaurus arm of the Milky Way galaxy, the Stephenson 2-18 is estimated to be 20,000 light-years away from the Earth. It's believed to have a size much larger than the older estimates for the UY Scuti. With a radius of around 2,150 solar radii, the Stephenson 2-18 could fit 10 billion stars the size of our Sun inside it. For perspective, if we replace our dear Sun with the Stephenson 2-18, the star would consume everything within the orbit of Saturn. This giant was first observed in 1990 by the American astronomer Charles Bruce Stephenson, using data from a deep infrared survey. Since then, many astronomers have begun to dispute the size of Stephenson 2-18 as well. This is because the theoretical limit for how large a star could be was placed at 1,500 solar radii. The Stephenson 2-18 exceeds this limit by around 750, meaning that a star this size shouldn't exist in the existing theoretical framework. But with great size comes great uncertainty. There is 50% relative uncertainty regarding how large Stephenson 2-18 actually is, meaning that there is a chance that it is actually much smaller than we believe it to be. Given how little we truly know about the universe, it shouldn't come as too much of a shock. In conclusion, the UY Scuti is not the largest star in the known universe. If it were to explode, it wouldn't really impact us on Earth, given that it's over 5,000 light-years away. While the Stephenson 2-18 is currently the largest star that we know of, our estimates regarding its size can very likely be wrong. When it comes to space, there is always very little that we actually know. One thing is for sure, it's not easy being a star, no matter what Hollywood says. See you all next time with more exciting content.